To write on this.
So, I think we're pretty solid on sequences and series in terms of just being able to get it, right? There's lots of practice, obviously lots of different types of questions that we can do, but I think you guys get the drift, right? Sequences are just different types. You can either have the numbers and get the sequence, or you can have the sequence and get the numbers, right? You don't know about that. Everyone else is
So the sequence isn't the numbers? The sequence is like the formula?
The sequence is just the sequence. A series is the adding of the sequence, the sum of the sequence.
No, but you said you could get the sequence and get the numbers,
right.
or get the numbers and then get the sequence.
Exactly.
So the sequence is like the formula of the numbers, or the numbers itself?
It's both, kind of. It's both. They're both, really. But what I mean to say is, like, I could have, like, an equals 2 to the n, and then get the different numbers. Or I can have 2, 4, 8, 16, 32, and then get, an equals 2 to the n. Right?
Hey.
That's what I mean.
What's the sequence? The numbers, formula.
This is the sequence. This is the formula of the sequence. Good. So I think we're pretty solid on that. I think we're pretty solid on series because it's a pretty straightforward concept. You have all the rules. I just want to cover. I just want to do one more, basically, of series. What was that? I just want to cover one more of the series so you guys don't get confused. Maybe two more. K plus 1 times k minus 3, sum from k equals 2 to 5. So obviously it can be any letter, it doesn't have to be I or N or anything, it can just be any letter. So k goes from 2 to 5. Any idea what I should do here?
Plug in 2. K equals 2.
Yeah, I could do that. I could just do that. Actually, I could just put in 2 and then go to the next one, put in 3 and then add that, and then 4 and then add that, and then 5 and add that. Right? I could do that. Actually, that's probably the smartest way to do it. I was going to tell you another way. But if you get confused, you can just FOIL it out, you know. Because you don't have any rules about that necessarily, right? But I could just FOIL it out and I'd get k squared minus 2k minus 3, right? And then I could separate them. But in this case, it actually would be smarter just to plug in each number and just go with it, right? Does that make sense?
So like that one would be like we plug in 2 for both k's there.
Yep.
And then we do that again.
Yeah, so for instance, it would be 2 plus 1 is 3, 2 minus 3 is negative 1, so it would be negative 3, and then I'd add the next one. Let me write it. 2 plus 1 times 2 minus 3, then I'd add to that, plug in 3, 3 plus 1 times 3 minus 3, then add to that 4 plus 1, 4 minus 3, and then I add to that 5 plus 1, 5 minus 3. Right? Pretty straightforward. Good? Okay. It's probably actually the smartest way to do it. I'm glad you mentioned that item. Another one that may look tricky, but is basically the same exact thing. I equals 1 to 4 of I minus 1 squared plus I plus 1 to the third. So this one looks pretty tricky too, but once again, we just plug in the numbers, right? So this would be 1 minus 1 squared plus 1 plus 1 to the third plus 2 minus 1 squared plus 2 plus 1 to the third plus 3 minus 1 squared plus 3 plus 1 to the third, and then the last is 4 minus 1 squared plus 4 minus 1 to the third. So I take it that's almost putting you guys to sleep at this point, right? Yes.
Yesterday, did you say putting it together was easier or putting it separate was easier?
Whatever you feel. Whatever it seems easiest to you, right?
What's quicker?
What's quicker? For instance, like in this case, it's probably easier just to do it like this. But it depends. It depends how much math you can do in your head, you know? Because if, for instance, if I had I equals 1 to 5 of I plus I squared, if it was hard for me to see, okay, 1 plus 1 is 2, and then put 2, then plus, 2 plus 4 is 6. If I can do that in my head, and just do this in my head, and then just write down the numbers, it's faster to do it this way. But if I can't do that, like in my head, and I gotta go in the calculator every time, then it might be easier just to do the sum of I equals 1 to 5 of I, plus the sum of I equals 1 to 5 of I squared. And in fact, this one you know is, well actually no. So
Is it
you
an easier
understand?
way to see it in your head?
What was that?
Separating would be an easier way to see it in your head.
Problem, it depends. Because like for this I could just do, 1 plus 2 plus 3 plus 4 plus 5 plus 1 plus 4 plus 9 plus 16 plus 25. And then I could just put that in my calculator, right? Does that make sense? So it's like I could just do it that way and separate it, or if I could do it in my head, I'd do, but whatever seems more accurate. Now, the question that you're asking is going to become more appropriate in just a second. Because what we're going to learn now is infinite series. When we're doing it these are called finite series. Why are they called finite series?
Because you have a lower limit and upper limit.
Okay, I have a lower limit and an upper limit. It's finite, right? They're also called partial sums because I only have a part of the sequence. I only have a part of the sequence. This is not. What are you doing?
I don't get this yet.
So you're on your computer doing Sudoku? Is that real? Is this really happening? You need to put that away.
I don't get it.
So, you think you're going to get it more by doing Sudoku?
No, I'm just waiting until I get this explained.
Okay, what? Ian, you need to get out of here with those things. Look at them, chuck that across the room. I wouldn't actually do that. Okay, so look, very simple stuff. It's very easy. Or not necessarily very easy, but sum from I equals 1 to 5 of I. Okay? What does this equal? Well, I changes. It goes from 1, then 2, then 3, then 4, then 5, right? So the first term is 1. Then the second term is what? 2. And the third term, 3, then, okay. So this is just a sequence. Remember we were doing sequences before? My sequence is I, so it would be like AN equals N. The only difference is this symbol here is a sigma. It means I add up the terms of the sequence. See? So I'm adding up the terms of the sequence from 1 to 5. My first term to my fifth term. I'm adding them up. Does that make sense? Cool. That's why it was like this. All I did is I plugged in 1, then I plugged in 2, then 3, then 4, and 5. You see? You see? I plugged in 1, then I plugged in 2, then I plugged in 3, then I plugged in 4. See? We just added them up. That was the sequence. Plug it in the terms, add them up. The only difference here is I'm adding up the terms of the sequence. That's what makes it a series. Got it? All right, now let's talk about infinite series. infinite series. So I would highly suggest you paying attention and taking notes, because this is good stuff here. An infinite series is okay.
The homework is only on this section, right?
Yeah, I'm skipping forward because we're not going to have a lot of time next week to go over the stuff that I'm going to be testing you on. So I'm going to be going into arithmetic and geometric series today. Okay, so an infinite series is when my sum goes from I equals 1 to infinity of some AI. Okay? So remember, A would be my sequence, my terms of my sequence, right? And now I'm going to infinity.
Is there such thing as a negative term?
Do you mean like starting from -3 or something? Yeah? What do you mean? Not generally in practice, because it would just, I don't know. Like it doesn't really make sense, because that's like saying like, I got -3rd place. It's like, that's better than 1st place. Like you would never say you got it. You know what I'm saying? Like, it's like this is the first term in the sequence. It wouldn't make sense to say this is the -3rd term in the sequence, right? It's like 1st, 2nd, 3rd, that kind of stuff. All right. So if I go to infinity, this is now called an infinite series. Okay? Now, most of the time, if I just go to infinity, the answer will be infinity, right? If, for instance, or not necessarily most of the time, but sometimes, right? If I just say my terms are all I, right? Then what is this sum? It's
infinity.
Right, because it's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 to infinity, right? So that's just going to be infinite. But there are some cases where you can get an actual solution. Let's talk about one of those cases. One of those cases is when I have I equals 1 to infinity of, let's say, 2 over 10 to the I. Okay? Wait, what? What's that going to be? I don't get it. Well, let's look. What's the first term? 2 over 10. Right?
Okay,
So the first, right? Yeah. Okay. Plus.
Like on the, like it's just one.
Yeah. Right. Okay. Yeah, okay. Gotcha. Alright, I didn't understand. I was like, 1 first. I don't know. Alright, okay. 2 over, next one is 10 to the what? 10 to the 2, or 2 over 100. Next one is 2 over 1,000. Next one is 2 over 10,000, and so on and so forth, right? Well, what's 2 over 10 in decimal? 0.2. Very good. And what's 2 over 100 in decimal? 0.02. And 2 over 1,000?
So it's 0.22222.
Ah, you got it. So the answer is, even though I'm going to infinity, I have an infinite amount of terms, my answer is just 0.2 repeating. Why do you think I can get an answer even though I have an infinite amount of terms? What is the key? What is the secret? Why?
Your answer has an infinite amount of numbers.
My answer has an infinite amount of numbers.
But
yeah.
it has.
But how can I have an infinite amount of things go into a finite thing?
You round.
No, not necessarily rounding. I'm not rounding. What do I?
It's like it just zeroes in every time.
It's converging. That's called converging. That's an idea. Converging. It gets closer. It's like an asymptote.
Yeah.
Okay. Like an asymptote. Yes.
Or like Yeah.
So, but what do I notice? What do I notice about the terms? What's happening with the terms? They keep getting smaller. So once I'm at, 80 jillion billion Googleplex, right? That's adding, 2. So it's adding such a small amount that even though I'm adding an infinite amount of terms, the amount that I'm adding each time gets smaller and smaller and smaller. So even though I have an infinite amount of terms, they add up to a finite number because they're converging, like what Missy was saying, to the same thing, 0.2 repeating. Cool? Okay.
Technically, it only was 10 over 10 or 10 later.
There are other ways to get it. We're gonna show how we can get that. There are other ones that will work with infinity. But the key, generally speaking, is that I have to be adding terms that are going to be getting smaller and smaller and smaller and smaller.
Always.
As far as I know, I don't want to say for sure, but that doesn't make sense, right? It does. Yeah. Yeah. I'll check up on that one to make sure, but yeah. The only way for it to go to a finite number is if the terms keep getting smaller. Okay. All right. So, good. Now, that's all for just the general, right? I could end up with, if I've got something like that, right? I could say I've just got some constant multiplied by 1 over 10 to the I, where I equals 1 to infinity. And that will just end up being point C repeating, right? Does that make sense? Does that make sense? Right? I've got some constant times 1 over 10 to the I equals 1 to infinity. Yeah, I mean, I could also write that as I equals 1 to infinity of C over 10 to the I, right? That would work. Why is it true that this does not equal I equals 1 to infinity of C over 10? And a better question to the I power. Why would this not necessarily give a finite number? When would this give a finite number? When would this give me some finite number?
C was a number smaller than
Very good. If C was smaller than 10, then it would be a fraction, and every time I square a fraction or multiply it by itself, it gets smaller and smaller and smaller, so it would end up as a finite number. If C was equal to 10, this would just be 1, so I'd just be adding 1 infinite times would be infinity. And if C was bigger than 10, very clearly, I would be getting bigger and bigger and bigger each time. Very good. So, now, let us learn about what's called arithmetic sequences.
You just moved on to the next section.
Yes. 8.2. Arithmetic sequences. We're actually going to cover arithmetic and geometric sequences. We're going to cover 2 sections.
Today?
Yeah. Well, maybe not necessarily today, but before the test.
Are we on track to like finish everything we're supposed to?
Yeah. Well, according to our syllabus, we're about 3 weeks behind. What? But
Wow.
I left 2 weeks in, and I left 2 weeks extra in the syllabus having time.
So we're 1 week behind.
We're fine. Put it this way, you ready? If we want to finish the course, this is why everything is okay. To finish the course, we have this much more of the book. We have gone over this much of the book. You guys see that? So,
We're almost done the third quarter?
no, we're halfway through the third quarter. So, we've done this much of the book, we have this much more of the book to do. And that's all the way getting into like calculus kind of stuff. So, we're good. Alright. Show arithmetic sequences. What is an arithmetic sequence? A sequence is arithmetic. Take this down in your notes. A sequence is arithmetic if the differences between consecutive terms are the same. Okay. A sequence is arithmetic if the differences between consecutive terms are the same. What does that mean?
It can't be an exponential. Or like, it can't be
So how is
that. Yeah.
Yeah. So what? Give me an example of an arithmetic sequence. Yeah. Very good. So the difference between consecutive terms are the same. Like for instance, I'm adding 2 each time, right? What was the form that we used for an arithmetic sequence? Where we're just like adding a to the n would equal what?
B plus, C plus C, B plus C. I know what
Yeah.
letters you use.
Yeah, very close. I would say like in your book it uses the letters DN plus C. Don't ask me why it uses the D there. DN plus C, where the difference, for instance, the difference between A2 minus A1 will equal D. Okay? So if I'm adding 2 each time, then D would be 2. Does that make sense? And C is just the constant that it's not necessarily the first term, right? Because the first term will be C plus D, right? But it's the constant that I'm adding to everything. So this is called an arithmetic sequence. We've been doing this already without necessarily knowing what it is. Okay? But let's get an example of an arithmetic sequence and see if we can get the sum. Let's say that AN equals 2n plus 4. Okay? What would the first term be?
1B.
N equals 1. What would the first term be?
Is that a plus or minus?
2 plus 4. 2n plus 4.
Oh,
6, right? And then what am I adding each time? 2. So the next one is 8. Next one is 10, 14, 16, 18, 20, 22, 24. We'll stop there. So let's see. N is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how could I write this sum? How can I write this as a sum?
Summation.
It means summation
I equals
1 to 10 of
2n plus 4.
2i plus 4 because we use I. Same deal. Very good. You guys all get that? Cool? Alright? So this is an arithmetic sequence. So my sum is from I equals 1 to 10 of 2i plus 4. Alright? Now, let's see if there's a secret way that we can figure out the sum without actually adding them up. You can imagine if I went up to 100 and adding them all up, that'd be very difficult, right? I don't want to do that. So what should I do? Well, I say my lower bound and my upper bound are fixed, right? I don't want to add up all these numbers. I want a secret, super smart way of doing it. Oh, very good. Well, maybe I can notice something about the numbers. Let's look
Make
at
an equation.
let's look at the numbers. Look at the first and the last number. That's a hint.
They're all kind of multiples.
Not necessarily. Look at the
What do you want to find?
I want you to see if you can see it by yourselves.
Add-
6
add-
times
I want to add them up.
The 10 term?
I want to figure out something secret and hidden in this list of numbers that is going to allow me to add them up without adding them all up.
They're even or divisible by 2.
Yeah, but look at specifically the first and the last number, and then maybe look at the second and the second to last number, and then these numbers, and then these numbers, and then these numbers.
They all add up to 30.
Very good. If I add 6 and 24, it adds to 30, and 8 and 22, 30, and 10 and 20, and 12 and 18, and 14 and 16. Right? They all add up to
30
30.
times 5.
Okay. So, and how many are there?
10. Oh, 5.
There are
Yeah.
5 pairs,
30
right?
times 5.
So, and how many terms did I have in my series?
10.
10. I had 10 terms in my series, and I have that first and the last number add up to 30.
That wouldn't be reasonable of an even amount of terms, right?
What about if I have 11?
Then these ain't big with your add to
One.
the last one.
What about if I had 11? Okay. Let's do the same thing. Let's do the same thing. Okay. 6 and 26 add up to 32. 8 and 24, 32. 10 and 22, 12 and 20, 14 and 8, and then 6 stands alone. 16 stands alone, but what is 16? 32.
Whoa!
Whoa. So I have 1, 2, 3, 4, 5 pairs, but I have 5.5 pairs, right?
You just add one.
So what do I do? My answer is if I
see we're both like, there's a number left, and you were like, what's 16? After.
Explosion. Okay, if I say Sn is equal to this sum, then this sum equals n, which is my final number. How many pairs do I have?
6.
I have
6.5.
5.5, right? So how many pairs do I have? I have n is 11. What's 5.5 compared to 11?
2 times.
2 times 5.5 would be 11, right? So I have n over 2 pairs of what?
5.
Wait, what?
Of 32. I have n over 2 pairs of 32. But how do I know that the number is 32? What do I have to add up?
Last.
Oh,
The
where n is
first-
11.
The first and the last, right? A1 plus A11 in this case. But the
Where n on the n on top of 2 is
Yeah.
11.
I apologize. I should have written this. The sum of I equals 1 to n of any arithmetic series dn plus c will equal this. In this case it was 11 over 2, or 5.5 times 6 plus 36, or 26, right? You guys see that? You guys see that? So it's 5.5, or 11 over 2, times the first number plus the last number.
This math is cool, Mr. Blaine.
Yeah. Okay. Cool. Very good. All right. So we see that instead of having to add them all up, now I want you guys to see how smart you are. Ready? Find the sum. Find the sum, and you can play this trick on friends. You can be like, find the sum of I equals 1 to 1,000. I equals 1 to 1,000 of 3i plus 4. Be like, they'd be sitting there adding up 1,000 terms, and you can get it. Go, no, paper, go. How do I do it?
Divide by 3.
Right? And in this case is 1,000. I think you guys can get it. On your head. Okay, how did you get that? Let's see, that's equal to what? N is 1,000, right? Over 2. What's the first term?
7.
Right? 3 times 1 is 3, plus 4 is 7, plus 3,004, which equals 500 times 7 plus 3,004 is 3,011. And that equals cool. Now imagine trying to add up all that up, right? It'd be very, very challenging. Now here's a question. I start at 1 and I go to 1,000. Shouldn't there be 9,999 terms? Right? I'm tricking you. No, there are 1,000 terms, right? I start at 1, so I'm including 1 to go to 1,000. If I started at 7 and went to 12, how many terms does that mean?
8. Wait,
7 to
so
12.
totally getting
6, right? So what do? I do the top one minus the bottom, and then I add 1. So let me show this in a written way. If I take the sum from I equals A to B, then the number of terms equals what? B minus A plus 1. So that's how I get my number of terms, which is what goes here. Okay? So this isn't always going to be this number. It will be this number if this is 1. Does that make sense? But if this is not 1, then you have to figure out the number of terms by doing b minus a plus 1. Does that make sense?
What was the formula for that one? Like the 1,000 over 2, what is that?
S of n equals n over 2 times a1 plus a2.
Cool. All right. Now let's do another one.
The next test is just going to be sequencing series or arithmetic sequence and geometric sequences.
Yes.
So if we learn this on Monday, what are you going to do? I mean, if we learn this on Tuesday, what are you going to do Thursday, Wednesday, Thursday?
Well, Wednesday will be the only other instruction day, and Thursday will be review.
And then Wednesday will be on the test.
Wednesday, I will be doing, very likely, I'll just be doing example problems in geometric series. I'll be presenting geometric series and doing example problems on Tuesday, and then on Wednesday, I'll probably just be doing more example problems. So, we're pretty good. If I wasn't able to do this today, we might have been in a little bit of a pickle, but we're okay. So we're good. We're gonna be fine. And like I said, we can, though, when do you get them out? Tuesday or Wednesday? Tuesday afternoon?
What?
Might be tough to get it.
Wisdom teeth.
You'll be okay. Are they impacted? They are? Mine were too.
How many? 3.
Yeah.
Mine.
I don't have
just-
one on this side.
You're just chilling? How many? 4 or 2? Yeah.
Dude, my brother
You'll be
has
okay.
2.
Lots of ice cream. And make sure you have plenty of
I've actually been eating anything I want this week.
They're just like
Nice.
inside they have the concept. Fine. They're just like anything.
Make sure it says pen or pencil.
My sister by mom, she was so crazy.
Dang.
Max is still in the
So
same
cool.
one.
He
He
was.
never it's there, but it hasn't worked.
This is weird on me.
When some doctors have
Never.
You like yourself?
I don't know, just feeling on the 3.
I see them in the X-ray.
Okay.
So I once had
Now, class. The important thing to be aware of when you're doing this is that it must be an arithmetic sequence. Okay? This doesn't work if it's not an arithmetic sequence. And remember, an arithmetic sequence is this form, dn plus c. Okay?
that one works.
Does it work?
No.
Yes.
Yes,
No.
it does.
It's the same
Because
thing
I
as
can-
1 over 4i
Oh, yeah.
plus 1.
I could rearrange this as 1 over 4i plus 1/2. That's d, that's c, right? Okay? Alright, go ahead.
We didn't give us fractions.
Of course I will. And I'm still very nice, thank you. But no, I'm gonna give you guys tough ones, of course. But you're gonna have an opportunity to do homework on it. Look, go ahead and do that now and then think it's so hard. It's not so hard. Do this one.
Calculator has that.
What?
Does our calculator have
Has the ability to do the sums? I'm pretty sure it.
8 3/4 times 15.
3/4. 8 3/4
Times
Yeah.
15.
times 15. What is that?
I don't want to pull it out of here.
Change this with me.
350, 575. It's 575.
It's not the same thing.
Should have read something. She's seen it.
She seems like she knows something about it. Okay. That should be the motion.
Is it cold
Hey,
today?
look, I found it.
7nation.
Outside. How do I? Because I was going to school.
Yesterday morning was
That's
like.
so cool. It's literally exactly.
Okay, why don't I
Oh, can you guys find this first?
I'm trying to solve it with my calculator, sir.
Well, okay, I'm gonna do it and then I'm bored. This is what? First term, n is what? 30. So 30 over 2 times the first term is 1/4 plus 1/2 is 3 over 4, plus the last term is 30 over 4 plus 1/2, or I could do it this way, right? I don't have to actually think about this one, I can think about this one, it's easier. 30 plus 2 is 32 over 4 is 8, right? That's my last term, makes sense? So this comes out to 15 times 8 times 4 is 32, plus 3 is 35 over 4 equals what? 525 over 4, which equals 125, 131.25, think? Okay. Hello, young lady.
Hi, can you sign something for me, please?
Yeah.
Sure.
This Rossi is sending you all out right now. It's very funny.
Yeah.
Fire.
I see the third. Why is it
She's good.
Why is it there?
Because he's flying though.
Wait, I thought I said what?
Oh, thank you.
Bye. Bye.
Bye. This is sweet. Okay. So, very good. Now, last one I want you guys to do, please do it. I equals 4 to 7 of 2i minus 1. Just real quick. How many terms does it have? 4 to 7.
Oh.
So you do 7 minus 4 is 3, plus 1 is 4. So it would be 4, these are 4 terms, over 2. The first term is not 2 times 1, it's 2 times 4 is 8, minus 7, minus 1 is 7. And then the last term is 2 times 7 is 14, minus 1 is 13. So 4 over 2 is 2, times 7 plus 13 is 20. This adds up to 40. No, it's not mine. Yeah, anymore. Got it?
I don't know. I put -2.
Good job, class. Got it? Yeah, and you're very much encouraged to figure out how to do this on your calculators. Obviously, on the test, I'll be looking to see this kind of thing. But you can always check your work.
Reassuring to know that